Okay, so today I'm going to talk about the homotopy groups of the space of knowledge. Okay, that's the title of the talk. Of course, at first we need to give some definitions. So definition one. So at first we need to define a space of knowledge. I don't know how to do it canonically, but I didn't come up with anything better than just the following. We could choose a language rich enough to describe the universe. Let's say English language maybe will fit. We actually don't know this yet for certain. And then consider the subset of all true statements in this language. And this subset will be called the space of knowledge. So now the natural question to ask whether the space have any topology. Ideally, we would even prefer to have a metric, but topology is a more basic question. In simple words, topology means the notion of neighborhoods. We could basically say whether two points in it are in some sense close to each other or not. Well, intuitively, at least naively, we would expect it to be the case. Let's say if this is your knowledge about Einstein general relativity theory, you could say that it's probably closer to your knowledge about differential geometry, which is basically the language of general relativity, than to say your knowledge about, I don't know, psychology or sociology. Right? And you could say somewhere in between of this we'll have, chemistry or, biology, somewhere here. So at least naively, we would expect it to be the case. However, our intuition could be totally wrong. It could be that all knowledge is secretly connected to each other, all pieces of knowledge, and they're all in some sense close to some sort of universal knowledge governing them all. Like, for example, if reductionism is true, everything just kind of follows from some sort of theory of everything through some very difficult calculation, maybe something like this. Or it could be even the opposite, that there's just no topology in the sense that the topology is discrete. Topology of discrete points, that every statement is just totally separate from other statements. Yeah, I played with it a little bit. I tried to define topology in certain ways, and actually I kind of failed. Basically, my naive guesses didn't work. So I decided to Google a little bit. And there is something which I found where people defined pre-topology. Yeah, see, I haven't actually studied the paper yet. I don't know whether it will be interesting. It's quite technical and pretty long. So I hope maybe we'll do it in the future. But for now, let me just assume that topology exists. Just today, I want to discuss what will be the interesting consequences of such a statement. Say the most interesting question to study about topology probably would be the homotopy groups. So first of all, what they are. Let me call our space of knowledge, for simplicity, by letter X. Basically, they're just maps of spheres into X up to continuous deformation. Or approximately. Just give this vague definition right now. For example, pi 0 of X just maps of points, equivalence classes of maps of points. Modular equivalence. So what does it mean? Let's say this is our space, and we consider all possible ways to embed point into it. If we consider two such maps, such that the image lies in the same connected component of X, so these points could be connected by continuous path. These two maps could also be continuously deformed into one another. But if X has multiple connected components, this part is also X, the map into this connected component could not be continuously transformed into this map here. So basically, pi 0 of X just measures the number of connected components. Which is already quite interesting, because we don't know what does it mean on practice. Is it possible that the space of all knowledge is disconnected space? That starting from our basic human knowledge, there are certain things which we could fundamentally never learn, like the Kant would call it a noumenal world, just beyond our reach. If we ever made contact with some alien civilization, could it be that their knowledge is like completely disconnected from ours? I think it's impossible. But we could just move on and ask what the next homotopy group means. Basically, pi 1 of X. This is an equivalent class of maps of circles, right? S1 into X. Loops, basically, map of loops. again, the equivalence up to homotopy, up to smooth deformation of this circular path. Basically, let's consider our x. Let's consider circle, like abstract circle, and so on. And I map it somehow, yeah, into x. Basically, it will look like some loop. Okay, so we see that if there is no hole here, we could smoothly deform this loop, contracting it into the trivial one, right? It will become a point. But if there is a hole here, like this, this map of a loop around this hole will be non-trivial. We can't contract it anyhow. Think about torus, actual torus. It has two non-trivial loops. One goes around this cycle, like this. And one goes around the big cycle, like this. So basically, pi 1 of x in some sense encodes this number of holes. Okay. But what does it mean to have a hole in the knowledge? what is it? How is it possible? Yeah, it doesn't even make sense. Basically, it's something like this. Imagine we have a statement A and a statement B. And we basically want to prove B knowing A. And maybe potentially knowing some other stuff. So we start making, logical implications. We move from A into some auxiliary statement, potentially with some influx of knowledge from outside, then into another statement nearby, potentially again with some knowledge from outside, and so on. Let's say this, I call this statement C. And then the same way from this statement C, they see some sort of big lemma, no way, fundamental lemma in our proof. We made our way towards B by some logical steps, small steps, so that in our topology, these 2 points are in the neighborhood of each other. I suggestively drew it like this, so half a boundary over square. Because now, let's try to imagine we have a different proof of the same statement from A. Potentially using some additional knowledge here. So proving certain lemma C prime. It's kind of natural to ask a question and whether these two proofs are equivalent to each other in some sense. What does it mean? Maybe they're just the same proof, just given in different words. So basically, we could ask, could we replace this lemma C by, slightly different one? Call it C1. such that you could cut this corner here. C1 follows from this statement and implies this one, still just like C. But we move our loop slightly closer to this half of the loop, slightly closer to the opposite half in the space of all knowledge. And we could repeat it several times. Do the same here with these two statements. Find these two auxiliary statements here and here, such that this one follows from this one implies C1, C1 implies this one, and this one implies this one. And we could start doing the same from the opposite side. Wait, I messed it up. The question then becomes whether we could completely join these two paths or not, whether at some point we will not be able to find the auxiliary statement here, which we'll need, which basically means that we have a hole in the space of knowledge, and this loop was non-trivial. This means these two proofs were fundamentally non-equivalent. Yeah, I don't know what would it mean, and is it even possible? Do we have examples of such proofs? It's hard to tell. Usually our knowledge is not structured like this. But we could even continue this logic further, just if we are completely brave and go to pi 2 of x, which is, again, maps of spheres already, actual spheres into x, equivalence classes of such maps. Basically, naively would mean something like this. It's like we have our statement A, statement B, we have one proof, we have another proof, but we know that they are actually equivalent already. We have this half sphere in a disk of different proofs filled between them like a cap, and in fact we have one way to show that they're equivalent and another way to show that they're equivalent, just the disk below. Here, the bottom half of the sphere. And the question then becomes, could we squeeze these two halves of the sphere to form like a single disk, or there is actually basically like this, to something like this, and finally to just flat disk. Or if there is a hole inside and you can't really do it, it's just not contractible really. Yeah, I don't know what could it mean, or just basically fantasies, and also whether it's anyhow useful for anything. Probably it's not. So, thanks for wasting your time.